The F-117 was the first warplane to be specifically designed from the outset for low radar observability. The Lockheed Advanced Development Company, better known as the Skunk Works, began working on stealth as far back as the late 1950s. During 1975, Skunk Work engineers began on an aircraft which would have a greatly reduced radar cross-section that would make it all but invisible to enemy radars. The technique that they came up with was known as faceting, in which the ordinarily smooth surface of the airframe is broken up into a series of trapezoidal or triangular flat surfaces, arranged in such a way that the vast majority of the radar incident on the aircraft from a source will be scattered away from the aircraft at odd angles, leaving very little to be reflected directly back into the receiver. An additional reduction in radar cross-section was to be obtained by covering the entire surface of the aircraft with radar-absorbent material, RAM. One of the disadvantages involved in the use of faceting on aerodynamic surfaces was that it tended to produce an aircraft which was inherently unstable about all three axes, pitch, roll, and yaw. The cockpit of the F-117 is covered by a large and heavy hood-like canopy with 5 separate flat transparencies, 1 on either side and 3 in front. The visibility from the cockpit is rather limited upward, downward, and to the rear. The canopy opens to the rear and has serrated edges in order to limit the radar reflectivity of the joint between canopy and fuselage. The 5 flat transparent panels are specially treated to further reduce the aircraft's radar visibility. The F-117 is unstable about all 3 axes and requires a fly-by-wire system in order to be able to fly at all. The fly-by-wire system is similar to that in the F-16 and is quadruply redundant. There are 4 independent channels which each control the same function. The signals from each of the channels are constantly being compared with each other, and if one signal is found to differ from the other 3, its channel is assumed to have failed and is automatically shut down. In the unlikely event that all 4 channels manage to fail at the same time, the aircraft cannot be flown and the pilot would be forced to eject. Upon such a failure, the stealth will start to wobble like a badly tossed football and tumble out of the sky. During the production run of the F-117, the 2 metallic all-moving tail fins were replaced with ones made of graphite thermoplastic materials. This change resulted from the loss of 1 fin and rudder from an F-117 in 1987 during a test flight. However, the aircraft landed safely despite the loss of the fin. The retrofit program was interrupted by Persian Gulf deployment, so most of the F-117s deployed to Saudi Arabia had the original metallic tail fins. With the fly-by-wire system working, the aircraft is highly maneuverable and a dream to fly. On enemy radar, she reads like a flock of birds. Steady and straight, the pilot could safely drink hot coffee out of a full cup, if he could have it. Of course, the F-117 is air refuelable. Most of the Air Force fleet is these days. An in-flight refueling receptacle is added behind the pilot's cockpit. A small light is mounted near the receptacle to guide the refueling boom operator in nighttime refueling operations. Mid-air refueling is one of the more difficult aspects of F-117 flight, since most of the time it is done at night, and the F-117's pilot upward vision is blocked by the canopy so that he cannot actually see the boom of the refueling aircraft. On December 19, 1989, just 13 months after the Pentagon had disclosed the existence of the F-117, it was used in combat for the first time. This was in Operation Just Cause, the invasion of Panama, intended to dislodge and arrest General Manuel Noriega. At the beginning of the invasion, 6 F-117s flew to Panama from Tonopah. Their mission was to drop 2,000-pound bombs near the Panama Defense Forces barracks at Rio Hato. The purpose of these bomb drops was to stun and disorient the PDF troops living there so that the barracks could be stormed and the troops captured with minimal resistance and casualties. The pilots were instructed to drop their bombs no closer than 50 meters from 2 separate PDF barracks buildings. On the night of December 19th, 2 lead F-117s each dropped a conventional 2,000-pound bomb at the Rio Hato barracks. The bombing attack seems to have achieved its goal, since the barracks were quickly taken with minimal resistance. However, it was revealed 3 months later that one of the bombs had missed its target by a considerable amount. It seems there had been some miscommunication in the final stages of the mission planning, and the pilot had been given the wrong coordinates for the target. The media jumped on this event and concluded that the F-117 had been a failure on its first mission. There are always those in the media who see controversy in expensive programs for the military and play it up. There are also those, and not just in the media, who question the need for an airplane like the F-117, especially since its role in combat is so limited, and the ship is subsonic in an age of fighters and fighter bombers that can do Mach 2 or better. The F-117's sole weapon is a stealthy, near-invisible approach, and its mission is to attack with complete surprise. Once the battle is joined, it is almost impossible to get a lock on it from the ground, and the ship flies and fights only at night. Flying by day completely obviates all its advantages, and under such circumstances would be extremely vulnerable to the meanest and greenest of enemy fighters or fighter pilots. The F-117 Nighthawk flies and fights with PGMs, or precision-guided munitions. Its targeting systems are so advanced they are not just tasked with hitting a particular building or installation, but with a specific part of it. Landing is a snap with fly-by-wire. Vectoring and glide path is handled by the computer. On a short runway, the F-117 Stealth needs a parachute in order not to overshoot its landing parameters. It was to be in Operation Desert Storm that the F-117 was to prove its mettle. In response to the Iraqi invasion of Kuwait on August 2, 1990, the F-117 was deployed to Saudi Arabia on August 19, 1990. In spite of the massive coalition buildup, President Saddam Hussein of Iraq stubbornly refused to withdraw his troops from Kuwait. On January 17, 1991, the coalition began an air offensive to oust him from the neighboring sheikhdom. The buildup of ground forces had commenced with Operation Desert Shield. Over 500,000 troops, mostly from the United States, would take part in both operations. Combat air patrols commenced almost immediately, with members of the coalition providing over 3,000 aircraft of every conceivable type. 6 carriers waited in the nearby Persian Gulf and Red Sea. Air crews and pilots came together from very diverse cultures for the effort. F-15s, 16s, E-3 AEWs, and the versatile A-10 Warthog tank buster all were there in force as well. Airplanes at bases in the region were staggered in their parking in case of Scud or enemy fighter attack. Carrier-borne Prowlers, an airplane based upon the old Intruder, would provide electronic warfare capabilities to the force. In overall command of the entire operation was General Norman Schwarzkopf. His officers called him Stormin' Norman because he suffered fools and errors in judgment badly. He had a specific plan for beating the Iraqis, and air power was to play the most important part. In the early morning hours, the F-117s of the 37th Tactical Fighter Wing initiated the air war against Iraq. Mission planners had assigned critical strategic Iraqi command and control installations to the F-117, counting on the aircraft's ability to hit precisely at well-defended targets without being seen. F-111Bs were also tasked on this night of the opening of hostilities. Other vital targets included key communication centers, research and development facilities for nuclear and chemical weapons, plus hardened aircraft shelters on Iraqi airfields, as well as planes left out in the open. On the first night of the war, an F-117 dropped a 2,000-pound laser-guided GBU-27 Paveway 3 bomb right through the roof of the General Communications Building in downtown Baghdad. In another attack on the communications building next to the Tigris River, another paveway was dropped through an air shaft in the center of the roof atop the building and blew out all four walls. During the first 3 weeks of the air offensive, F-117s obliterated many hardened targets with unprecedented precision. The 37th Tactical Fighter Wing flew 1,271 combat sorties and maintained an 85.5% mission-capable rate. The 43 F-117s of the 37th dropped more than 2,000 tons of precision ordnance and attacked some 40% of the high-value targets that were struck by the coalition forces. Not one F-117 was hit, shot down, or lost to mechanical failure. There is no evidence that the F-117 was ever detected or tracked by Iraqi radar installations, either ground or airborne. The F-117's concealment, deception, and evasiveness proved that it could survive in the most hostile of environments, and its laser-guided bombs struck with extreme accuracy. U.S. ground forces included many women in support roles, and some came under hostile fire. Most of the F-117s deployed to Saudi Arabia returned home to Nellis Air Force Base in April of 1991. The ongoing tension in the Middle East has seen the F-117 stationed in the region repeatedly. Its mission, like in the Gulf War, was to strike first at enemy aircraft positions to clear the way for conventional fighters. Rising into the air like a vampire with the last rays of the sun, the Nighthawk has proven itself a formidable asset under combat conditions. The F-117 has no air-to-air capability, or at least none that has been announced to the general public. It has no radar, does not carry an internal cannon, and is not equipped to carry or launch air-to-air missiles. The F-117 cannot rely on radar for navigation, weapons aiming, or weapons delivery because the transmission of a radar signal would tend to give away the location of the aircraft and hence defeat the whole purpose of stealth. For low-level navigation and weapons aiming purposes, the F-117 aircraft is provided with forward-looking infrared, FLIR, and downward-looking infrared, DLIR systems. The FLIR is mounted in a recess just ahead of the cockpit front windshield. It is located in a steerable turret containing a dual field of view sensor. When the FLIR is not in use, it is rotated 180 degrees to keep debris from damaging the sensor. The DLIR system is located in a recess underneath the forward fuselage and to the right of the nose landing gear well. Both the FLIR and the DLIR recesses are covered by a RAM mesh screen to prevent unwanted radar reflections from the active elements, and the edges of the recesses are serrated, with the fasteners being covered with RAM putty. The DLIR is provided with a bore-sighted laser for illuminating the target for attack by laser-guided weapons. Together, these systems form the Infrared Acquisition and Designation System, IRADS. The laser is slave to the IRADS and is an integral part of the infrared system. The spot size of the laser on the ground is about 12 to 18 inches, and the spot is stabilized in position by the IRADS. A highly accurate inertial navigation system, INS, backs up the sensors. This system uses an electrostatically suspended gyro as the primary means of guidance. The INS guides the aircraft to the immediate target area and points the FLIR's wide-angle field of view toward the general location of the target. As the aircraft approaches the target, the pilot monitors the view presented by the FLIR on the heads-up display screen. When the specific target is identified, the pilot switches to the narrow view on the FLIR and locks the screen of the display onto the target. As the target disappears underneath the aircraft, control is handed over to the DLIR, which acquires the target then and continues to track it. When the pilot decides to attack, he releases a laser-guided paveway bomb. Approximately 7 to 10 seconds before bomb impact, the DLIR's laser is turned on and illuminates the target, and the bomb homes onto the reflected infrared laser light reflected from the target. Videotapes from the FLIR-DLIR displays that have been released to the public by the DoD have shown that the F-117 flying during a clear night can hit a target only 1 meter in size from an altitude of 25,000 feet. A parachute braking system is provided since the lack of flaps makes the landing speed quite high, 160 knots, or almost 200 miles an hour. The braking parachute is housed behind split doors atop the rear fuselage. The braking chute is deployed as soon as the nose wheel makes contact with the runway. The parachute can also double as an emergency anti-spin device if needed. The windshield is coated with a special gold film layer to prevent the pilot's helmet from being detected by radar. This was found to be an important problem during early tests. The pilot sits on a McDonnell Douglas Aces II ejector seat, the same type of seat that is fitted to the F-15. The cockpit is large and roomy, even if the airplane's sightlines are not the best. Just about every opening hatch on this aircraft is serrated to further break up a radar reflection. Maintenance is constant and ongoing. Since external hardpoints for bombs or fuel tanks are taboo for a stealth attack aircraft, all stores must be carried internally. The weapons bay is located in the belly on the center line. It has 2 wells, each covered by an inboard opening door. The weapons bay can accommodate up to 5,000 pounds of ordnance, 2,500 pounds in each well. The The crews are not above taking memorabilia photos of their work during Desert Storm. It will be something to tell the children and grandchildren about in years to come. 2 laser-guided Mk-84 2,000-pound bombs are included in the Bombay Ordnance packages, as well as other types of precision-guided munitions, including a panoply of paveway weapons in varying poundages. The mounting systems for these weapons are very complex, and great care must be taken with individual weapons as they are hooked into the weapon's electronic grid and fire control system. If one of these should hang up in the bomb bay, it could jeopardize the mission, the aircraft, and the pilot. Generally speaking, United States Air Force, Marine, and Navy maintenance crews are the best in the world and receive intensive training in all aspects of the work they must do. They know the pilot is up there, hanging in the air on the strength and quality of their efforts. Individual pilots, quite understandably, have a high degree of respect for their support crews, who tend to think of their individual aircraft as their own personal property, which they occasionally lend to the pilot. He is frequently admonished to bring it back without any holes in it. The F-117 Nighthawk looks like it's moving even when standing still. A traditionally trained seat-of-the-pants pilot has some difficulty early on with fly-by-wire simply because so much of his usual work is done for him by the onboard system. Although the F-117's role was initially viewed as limited to its special talents, it is now being considered for more expanded uses, partly to quiet its critics. The GBU-24 Paveway 3 is a more advanced version of the Paveway 2 with a larger tail surface and more efficient guidance system, which permits it to be used at lower altitudes and at greater distances from the target. This gives the Nighthawk still more of an advantage in its primary role of foment-bending surprise. Although the F-117 has been called Frisbee, Nighthawk, and Wobblin' Goblin, there is no official name for it. Pilots often call the F-117 simply the Black Jet.
In our current tasking, we are exercising a wide spectrum of missions which the F-117 can be tasked for. These range from counter-air targets, offensive counter-air, suppression of enemy air defenses, and of course air interdiction. Currently, our wing is tasked at approximately 34 sorties per night tasking. Our primary limitation with being able to support that level of tasking centers around not only the number of aircraft assigned, but the duration of our sorties. Based on our location, each sortie averages somewhere between 5.5 to 6.5 hours, and you consider the restrictions that we have to limit our operations north of the border to night only. As the days become shorter, of course, our sortie duration and our ability to turn and generate more sorties will be somewhat limited. However, not significantly. I'm talking onesies and twosies, and we should be able to sustain the high level of sortie activity I previously described for some time to come.
The F-117 is currently out of production, but the Senate Armed Services Committee expressed an interest in acquiring 24 additional F-117s. However, the Air Force claimed that the F-117 is now obsolete technology and that it did not need or want any more of them. The last production F-117 was delivered to the Air Force on July 12, 1990. Ever since the first atomic bombs were dropped by B-29 superfortresses on Japan in 1945, the U.S. Air Force has seen the manned bomber as a crucial part of America's nuclear deterrent. Perhaps the ultimate bomber is the B-2 Spirit. It may well be the last of its kind. The B-2 development program was initiated in 1981, and the Air Force was granted approval in 1987 to begin procurement of 132 operational B-2 aircraft, principally for strategic bombing missions. With the demise of the Soviet Union, the emphasis of B-2 development was changed to conventional operations, and the number was reduced to 20 operational aircraft, plus one test aircraft that was not planned to be upgraded to an operational configuration. Production of these aircraft has been concurrent with development and testing. The first B-2 was publicly displayed on November 22, 1988, when it was rolled out of its hangar at Air Force Plant 42 in Palmdale, California. Its first flight was July 17, 1989. The B-2 Combined Test Force, Air Force Flight Test Center, Edwards Air Force Base, California, is responsible for flight testing the aircraft as they are produced. The B-2 Spirit is a multi-role bomber capable of delivering both conventional and nuclear munitions. Along with the B-52 and B-1B, the B-2 provides the penetrating flexibility and effectiveness inherent in manned bombers. Its low observable or stealth characteristics give it the unique ability to penetrate an enemy's most sophisticated defenses and threaten its most valued and heavily defended targets. Its capability to penetrate air defenses and threaten effective retaliation provides a strong, effective deterrent in combat force well into the 21st century. The blending of low observable technologies with high aerodynamic efficiency and large payload gives the B-2 important advantages over existing bombers. Its low observability provides it greater freedom of action at high altitudes, thus increasing its range and a better field of view for the aircraft sensors. Its first rollout and testing was given an enthusiastic response by the workers who helped construct the ship. The B-2's low observability is derived from a combination of reduced infrared, acoustic, electromagnetic, visual, and radar signatures. These signatures make it difficult for the sophisticated defensive systems to detect, track, and engage the B-2. Many aspects of the low observability process remain classified. However, the B-2's composite materials, special coatings, and flying wing design all contribute to its stealthiness. The B-2 has a crew of 2 pilots, an aircraft commander in the left seat and mission commander in the right, compared to the B-1B's crew of 4 and the B-52's crew of 5. A chase plane keeps an eye on the new ship and watches for any external signs of trouble or problems that might develop in the test flight. After all, this is a ship that cannot fly without its fly-by-wire system. This involves 4 redundant computers, each in continuous communication with the others. Should one of them fail, the other 3 will shut it down and take over its function. In the unlikely event that all 4 should ever fail, the B-2 will plummet like a stone from the sky. The flying wing is inherently unstable, and without the computers constantly adjusting its trim, It has all the flight characteristics of the proverbial lead balloon. But today, the initial test flight went off as smooth as silk. And congratulations are tendered all around to the pilots and to the designers by the Air Force, which has been waiting for just such a ship. The F-111 and the B-52 had handled the American Air Force nuclear deterrent almost exclusively prior to the B-2. Both ships could carry and handle not only nuclear bombs, but conventional PGMs, or precision-guided munitions. The on-again, off-again B-1B was also suited for these tasks, and almost concurrent in its production schedule with the B-2 development program. Congressional critics quite understandably wanted to know why the Air Force needed both of these very expensive aircraft, especially given the fact of submarine-launched missiles. The B-2, although not supersonic, could theoretically sweep through Russian radar and deliver its nuclear bomb load, providing a new complement to the sub-launched missile fleet. The special design of the B-2, combined with the unique skin of the aircraft, make it almost, but not totally, invisible to radar. The whole B-2 design was based upon this unique radar and heat-absorbing skin. Its engines have very reduced emissions to keep the infrared profile low. But a problem has since developed with the special coating applied to the skin of the ship. Northrop was embarrassed by the tendency of the coating to peel away after being subjected to no more stress than a rainstorm. Critics have called the B-2 a hothouse airplane and unable to withstand the stresses of the real world. It's an ongoing problem that Northrop is addressing even now. The Russian Su-27 is one of the latest fighters to come off the Russian production lines, given special avionics to help it see the stealth bomber at night, the only time it would be flying. For the Soviets to counter the B-2, it took a major revision of their air defense systems. Having to worry about strategic bombers sneaking in was an idea that seemingly had become obsolete. But the B-2 made the problem real again. Billions would have to be spent by the Russians to counter this new threat. By the end of the 1980s, the Soviets simply didn't have the money to keep up with the West. With the extreme cost of the B-2 program, each plane had cost hundreds of millions of dollars, made it a weapon system that the United States itself could barely afford. Indeed, some would argue it can't afford it now. But it's out there now, a fact on the ground and in the air. The B-2 Spirit is a very expensive, strategic, long-range, multi-role bomber, and tests show that with its low observable stealth characteristics, the B-2 is the most survivable aircraft in the world. One of the 6 flight test B-2s remains in an extended testing program at Edwards Air Force Base, California. "16 B-2s have been delivered to the operational fleet at Whiteman Air Force Base, Missouri. In their first 3 years of service, operational B-2s achieved a sortie reliability rate of 90%. The B-2's low observability means that it doesn't need an armada of support aircraft to accomplish a mission, and its large payload allows it to do the work of many smaller attack aircraft. The Air Force has published a representative mission scenario showing that 2 B-2s armed with precision weapons can do the job of a package of 75 conventional aircraft. Only 4 B-2 crew members are put at risk in this mission, compared to 132 in the conventional aircraft package. The B-2 can fly more than 6,000 nautical miles unrefueled, and more than 10,000 nautical miles with just one refueling, giving it the ability to fly to any point on the globe within hours. The B-2 can carry up to 20 tons of conventional and nuclear ordnance and deliver it accurately under any weather conditions. Significantly, a single B-2 can deliver 16 one-ton near-precision munitions. The flying wing concept was very close to the heart of Northrop founder Jack Northrop. He was one of the pioneering giants in aviation. As early as 1923, Northrop had been convinced that the flying wing, in which the aircraft carried all loads and controls within the wing and dispensed with fuselage and tail sections, was the next major step forward in aircraft design. This is the YB-49. It was the successor to the propeller-driven BB-35 developed during World War II. The YB-35 project was bedeviled by problems and mishaps, but the Air Force still considered the flying wing concept as having merit. On June 1st, 1945, a contract ordering the conversion of two of the YB-35 flying wings into jet configuration was issued. The four Wasp major engines of the B-35 were to be replaced by 8 4,000-pound thrust Allison J-35A5 turbojets buried inside the wing, 4 on each side. The engines were to be fed by intakes cut into the leading edges of the wing. The designation given to the jet-powered flying wing bomber was originally supposed to have been YB-35B, but this was changed to YB-49 before the first flight took place. Since the addition of jet power promised a marked improvement in the performance of the flying wing, work on the YB-35 project was abandoned, and plans were made to convert all the YB-35 airframes beyond the first to YB-49 configuration. The crew of 7 were housed entirely within the wing center section, with the pilot seated underneath a large bubble canopy near the wing leading edge. For long flights, an additional off-duty crew of 6 members would be carried in quarters in the tail cone just aft of the flight section. Conversion of the YB-35 to the YB-49 configuration was originally scheduled to be completed by June of 1946. However, this schedule slipped by more than a year because of unforeseen problems encountered in adding fins to the wings. The first YB-49 took off on its maiden flight in 1947 from the Northrop Field at Hawthorne, California, piloted by Northrop's chief test pilot, Max Stanley. At the end of the flight, it landed at Muroc Air Force Base, where it was to carry out its test program. It was later joined by the second YB-49, which flew for the first time in 1948. Over 20 months of flight testing were carried out on the two planes, with hundreds of hours of flight time logged in the ships by both Northrop contract test pilots and Air Force pilots. A maximum speed of 520 miles an hour was achieved, and a service ceiling of 42,000 feet was attained. A normal 10,000-pound bomb load could be carried for an estimated 4,000 miles on 6,700 gallons of fuel, less than half the range of the piston engine B-35. In spite of the added rudders and wing fences, the YB-49 design still encountered some stability problems which were never fully corrected. On April 26, 1948, the first YB-49 achieved a milestone of sorts, the aircraft staying up in the air for 9 hours, 6 of which were above 40,000 feet. This is believed to have set an unofficial world record for that period. On May 28, 1948, the second YB-49 was turned over to the U.S. Air Force. Only a few days later, tragedy struck. On the morning of June 5, 1948, it crashed just north of Muroc Dry Lake. The pilot, Air Force Captain Glenn Edwards, and all 4 members of the crew were killed. What caused the crash is not known, but it was suspected that Captain Edwards managed to surpass the red line speed of the aircraft while descending from 40,000 feet, causing the outer wing panels to shed and the aircraft to disintegrate in midair. Muroc Air Force Base was renamed Edwards Air Force Base on December 5, 1949, in honor of the late Captain Glenn Edwards. In spite of the crash, the Air Force still had sufficient confidence in the YB-49 that they continued with plans for the conversion of 9 of the remaining 7 YB-35 airframes. They were to be altered to a basically similar RB-49B strategic reconnaissance configuration with 8 jet engines, with another airframe to be used as a static test vehicle. In addition, orders were placed for 30 new RB-49s to be built from scratch. Many deficiencies turned up in the second series of tests. The Test pilots complained that the aircraft was extremely unstable and difficult to fly. The J-35 turbojets of the YB-49 were extremely thirsty for fuel, and the jet-powered ship had only half the range of the YB-35 that preceded it. They also maintained that the YB-49 was completely unsuitable as a bombing platform. It could not hold a steady course or a constant airspeed and altitude, and that there was a persistent rocking motion and yaw, which tended to upset the bomb sites. The problems encountered were enough to kill the program. Politically, the B-2 has been controversial since the beginning of its development, because much of its cost was predicated on the needs of the Cold War. To a degree, its new missions, particularly conventional ones, must be developed in order to maintain support for the project. The Air Force has worked hard to achieve both an ongoing nuclear role for the B-2 as well as a conventional one. The B-2 has had to compete for scarce Defense Department dollars during its test phase. Virtually every other major weapons program in the American military is also short of funds. The B-2, because of the enormous amount of money required for each plane, makes it a constant target for those seeking economies in the defense budget. Still, its advocates say the B-2 is a unique airplane, capable of performing missions no other weapon system can perform. There is still the ongoing problem of the peeling skin. The plane needs constant maintenance in this regard alone. Whiteman Air Force Base, Missouri, is the B-2's only operational base at the moment. The first aircraft, Spirit of Missouri, was delivered December 17, 1993. Perhaps the B-2's single most difficult hurdle out of all that it has faced in order to become operational is the collapse of the Soviet monolith in 1991, barely a decade after the flying wing concept was revived and its further development assured. Curiously enough, the Air Force is still fighting to keep the B-2, after having decided it does not need or want any more F-117 Nighthawks, which preceded the B-2 in development. Congress has recently been asking another embarrassing question of the Air Force in Northrop. One of the hardest things to figure out is why the skin coating on the F-117 is not peeled, as it has on the B-2, especially since both are made out of the exact same material. Computer simulations have not yet found the solution. Helicopters have been painted with material as an experiment, and to date no peeling has yet been noted. The B-2 has also to compete with the newest Air Force superfighters for scarce funding. Now that the B-2's main mission and reason for existence has been obviated by lack of any conceivable strategic threat, the Air Force has been stressing the big bomber's conventional capabilities and how it might be used in small wars like that fought in 1991 in the Persian Gulf against Iraq. Although that was not really a small war when you consider that 500,000 men were under arms. Mission specialists at consoles are always on the lookout for any new missions the B-2 would be particularly adept at fulfilling, like the addition of cruise missiles to its armament. Looking more and more like overkill in today's world, the ICBM still remains the greatest strategic deterrent the U.S. has. The cruise missile, on the other hand, with its ability to be launched miles from a target, is becoming a preferred means of conducting deep strikes. The F-117 proved beyond a doubt the whole concept of stealth during the Gulf War. It led off the attack against Iraq and destroyed all of its assigned targets without the loss of a single ship. Defense workers and contractor employees, of course, hope that the B-2 will continue to enjoy funding by the Congress. Even before November of 1988, When the first one rolled out, they have been enthusiastic supporters. They want to keep their jobs. Many of today's defense workers are sons and daughters of those who were there in the beginning of the flying wing concept. Most of them are involved in the day-to-day process of trying to correct the remaining difficulties the B-2 faces, such as the peeling paint problem and ergonomic placement of some of the ship's avionics. All of this involves heavy-duty computer modeling and simulation. It seems hard to imagine that after all the design work that has already gone into the plane, there could still be major improvements. But the search for better answers never ceases, even when what exists works perfectly well. The old adage, if it ain't broke, don't fix it, is foreign to Northrop design teams. Anything that will improve the stealth characteristics of the ship or will help it defend itself if attacked is constantly chewed over and thought about at all levels of the design production team. If a new solution is found that works better than the one in place, the company then checks with the Air Force procurement team for authorization to incorporate it. Some changes make it, others do not. Often it's a question of money. How expensive will it be to incorporate the change? What else will have to change as a result of making the first change? This is not an easy process, and burnout is a mental challenge everyone faces in the quest to make the B-2 the best it can possibly be. Often the ideas coming out of the Skunk Works have ramifications that have nothing to do with the practicalities of changing the B-2 itself. Many of the ideas can also be used as ammunition to counter the plane's critics in Congress. Satisfactory explanations of why this or that gadget or other new piece of equipment is needed can sway decisions on Capitol Hill. Design specifications are printed out and distributed to all members of the team, who then weigh each new proposed change. They then must file their own reports on what the change will mean for their department. All systems must integrate as seamlessly as possible. The pilot and his weapons officer have enough to worry about on a mission without the added burden of something unforeseen going wrong with the aircraft. With all four computers and the fly-by-wire system functioning normally, the ship is a very stable bombing platform that is practically invisible on radar. 3 of those computers could fail and the B-2 could still fly straight and steady. But if that were to happen, the crew could fly on to complete the mission, no doubt with extremely elevated heart rates. If the 4th one goes, the only ace in the hole is ejection, possibly over hostile territory. That is why the design team of the B-2 is so hard at work on a continuing basis. The possibility for disaster must be kept at an absolute minimum. The B-2 remains in testing. It will be part of the American Strategic Bomber Force for many years. To a degree, it is an airplane in search of a mission, but there are many in the Air Force that are glad the plane exists. For when that mission arrives, the B-2 and its crews will be ready.